So, okay, what is Eddy's theorem? Bending moment is proportional to the vertical intercept between the linear arch and the actual arch. Okay, see this problem, same problem, same problem. Once again, I will solve it, not solve it. So, what is the problem now? Statement of problem. So, 120 at the rate, it's 12 meters. 12 meters total is 36. 36. This is 8 at 12. At 12, it's 120. Okay, so that's it now. That's it. What is the bending moment here? So you can directly calculate it. See, it is, you already know. You have to find out the reactions. We already solved it. What is the reactions? See, the reactions are 80-40. Okay, we already calculated 80-40, and bending moment horizontal reaction is 180. So you can represent bending moment diagram like you can represent a bending moment diagram. There's a perfect arch. Perfect arch. Take is that as a perfect arch. Later, it is a 120 na? It's a 120. So if you put a 120 at that, not a 120, if you put a load at that point and you just drag it, take it as a search, just drag it. What will happen? It will happen like this na? So that is a funicular structure. How can a funicular structure will happen? So we already know. That's it. That's it. Na? Tell me. It is 0. Just okay. Okay, take it as a 0. So okay, that's it now. Funicular structure, we drag it. Okay, so that's it. That is the bending moment. So what is that bending moment? We find out. But what I said is bending moment is proportional to the yt minus y. So what is that? Yt is a theoretical arch and y is the actual arch. Okay, if you see it is just see. So you know what is exactly height of the actual arch. So what is the exactly height of the actual arch? At that location it's a 12 meters now. It's a 12 meters. What is exactly height of the height at? So 5.33. You know, it's a 5.33. Okay. So it's a 5.33. And what is the value of this total height? Sir, how can you find out the total height? I will see. So if you see, it's just a bending. It's just a loading up there. Just a loading. It will come. That's it. No? So you want to find out the loading. Okay. Just take it. Just take a unit load. Just a unit load. This something. This A. This is B. Just a unit load. Just one unit. So if it is x, it is L minus x. So what is that value? Bending moment. So it represents bending moment. It represents bending moment. I already explained funicular structure. What is funicular structure? It represents bending moment. Bending moment. So what is the bending moment? That is a P. Bending moment is what? Bending moment is what? P A B by L. That means what? P x into L minus x by L. That is a bending moment. I said just unit load. One unit load. The P is taken as a just only one. P is taken as just one. So taken as just one. What is that value? See it is. Now in see in this diagram. Sir, why only one, sir? We have applied some 120 kilonewtons now. I will explain it. Okay. Just taken just one. Just taken one unit load. So what is the height? What is that height? What is that height? It's a 12. 12 this is. What is that value? Total is 36 now. This is 24. 12 into 24 divided by 36. What is that value? 12 into 24 divided by 36. What will happen? This is 8. It is 8. So okay. So that means theoretical is 5. That's not a theoretical. Actual arch is 5.33. Theoretical is 8 meters. So bending moment is directly proportional to the 8 minus 5.33. What is that value? Answer minus 5.33 is 2.67. Sir, why you taken only one unit, not a 120? Sir, so exactly if you see it is bending moment is equal to the h multiply with yt minus y directly. So what is h? So h is directly we know 180. 180 minus 180. It's 480.6. See what is the bending moment? There is. What is the bending moment? See what is horizontal reaction? It's 120. Sorry. 120. Okay. So sorry. This is 120. This is 120. So 120. 120 multiply with 2.67. See it is get 320.4. 320.4. See what is that value? See 320.4. Exactly we will get it like this. That is the theorem. Sir, why you applied only one unit, not a 120, not 120? That is the question. See, you just taken one unit load. That is the theoretical arch. Just taken one unit, you will get the shape. Sir, what is the effect? Sir, if it is applied 120 or 60 or something, any other value also same value, na? No. If you applied different value, the horizontal reaction is changes. The effect will goes to horizontal reaction. The bending moment is horizontal reaction multiply with this, na? So if you apply different loading, the h will change. The h will change. So no problem at all. The effect is included in the h, na? The effect is included in the h. So this theoretical arch height, the theoretical arch vertical intercept will taken for one unit load. Taken for just one unit load. Okay. So if you observe it, exactly center crown point taken as a crown point. Crown point. This is also has hinge, na? So if you taken exactly some point load is applied at exactly on a crown. If you taken exactly this half with this half, x into x divided by 2x. So what will get? What will get? So x. This is x. This is x. This is 2x. X by 2. X by 2, na? So x by 2 means this value. This value will get. This value is will get. This is x. This is x. This is exactly circular curve. This is x. This is x. So what is that value? I can't understand. Something. This is if you applied something 18, 36. 18 by 18, that is okay. So 18 by 18 is 9. 9 you will get. 9 you will get. So if you observe what is that? That is it. If you observe, 9 will get, where it is, sorry, no need to take in that example. That example is too silly. Okay, leave it that example. So okay, I just took in some wrong example. Okay, so taken, that's it. If you see, it is the bending moment. The bending moment is directly you can take in as h into yt minus y. This is a Eddy's theorem. Okay, this is Eddy's theorem. Okay, this is equal to Eddy's theorem. So what is the y? Vertical intercept. This is y is actual arch. So okay, this is y is actual arch. Okay, so that yt will take and just apply a unit load. Just we take an applied unit load. If you applied a unit load, how much is the this vertical intercept? You will easily get by bending moment diagram. So x into L minus x divided by L, PAB by L, that is a bending moment diagram. So you will delete it. P, so only one unit load. So you will get that yt. So yt minus y multiply with h. So if something different load is happened, so the difference will get into the, we incorporated that effect into the h. That's it. If different values are acting, the h will change. So no effect. So that's it. So you can get the bending moment like this also. That is the Eddy's theorem. Final. Okay. Final idea. Okay. That's what I missed last class. Okay. So that's it. So today I will took so many remaining examples. Okay. So 20. Okay, so remaining examples I will took something like, we can easily solve, you can easily solve for this. This is also hinge. You can easily solve different loading, anything. Okay, so anything, any loading you can easily solve, because 4 equations, 4 unknowns, no problem at all. This is no problem. If something arch is like this, sir, what is that arch? This is my crown point. What is this arch? So this arch is, see, the ground supports are not exactly on same plane. This is also same arch. This is also parabolic arch. But the ground supports are different levels. So how can you solve? So same thing, no problem at all. But if you see, maybe he gave like this value. This value is L. This value is taken something like, this is H1 up to this, total is H2. Okay, total is H2, only up to this wall is H1. So for this AC, this is B. So BC arch has a BC has a rise of H2. AC arch has a rise of H1. These are all parabolic. Okay, how can you solve it? You can solve it, but we don't know what is exactly this L1, this L2. If you know this L1, this H1, you can easily find out wherever the height, wherever you require the height, you can easily find out by this L2 and H2. That's it, no? You can easily find out. But what is the value of L1, L2? How it is shift? How can you find out? So you can find out, see, just a very simple. We already know it. You already know it like what you know? You already know it like L1 divide. So L1 square divided by H1 is a constant. You know it, no? You know it. X square by y is a constant, na? You know that is a parabolic property. And also if you see L2 square by H2 is also constant. That is the same. That's it, na? That's it. But if you see, this is a total. This is a total a parabolic. What is that parabolic? ACB is a parabolic of only one parabolic. One arch. This is a one arch. It total one arch. Are understood? It's a total one arch. So in one arch we have only one constant, not a two different constants, not a different constants. These two are same. These two are equal because this is a totally a arch, simple arch, parabolic arch. Both are equal because this property. This is a one simple parabolic arch, but different levels are different. Not a parabolic. It's a parabolic of only one. Okay, so these are two are equal. You see it is, you can write like this. This is, I can write like L1 by root H1. This is also I write like L2 by root H2. But both are equal. Both are equal because it is a one parabolic. Okay, we will take just half and half, not an half. This is one part, round part. This is the second part. But total we have the same same is applied throughout the span, okay. If you see it is L1 by root H1, L2 by root H2, if it is equal, then you can write like this L1 by L2 by root H1 plus root H2. You can write it now. Sir, how can? You see 2 by 3 equal to 4 by 6. 2 by 3 is equal to 4 by 6. Then you can write 2 plus 4 by 3 plus 6. You can write it now. See, it is 6 by 9. 6 by 9. It is a 2 by 3 na? Understood? You can write it na? Maybe you lost your memory in school days. You can write it. So if you see, if you write it, L1 plus L2 is L. So then you can write L1 is equal to, what is L1? L divided by root H1 plus H2 multiply with root H1. Same you can write L2 is L root H2 divided by H1 plus H2. You can write like this. If you segregate like this, if you find out L1 and L2, what is L1 and L2? So later you can easily solve any problem. You can solve any problem. No problem. Okay. Is there any problem? Nothing. No problem is there. Okay. No problem is there. Okay. That's it. So we will solve one problem. No problem. Okay. Now we will solve one problem. So see it is. See it is. We will solve one problem. It is a crown. It's a parabolic. So three hinges parabolic. A, B, C. This is also hinge. Okay. This is also hinge. This is a 3 meters. We write like a, this is a 3 meters. You said this is 3 meters, and this total is 5 meters. Okay, total is 5 meters, and later he said that total distance is 40 meters. Total span length is 40 meters. And the application of load, see, application of load is application of load is 30 kilonewton per meter. They applied load like this, 30 kilonewton per meter, only half span. Okay, so what he asking? What he asking is horizontal thrust. So find out the H value, horizontal thrust, and also at 15 meters, see it is, find bending moment, normal thrust, and radial shear force developed at a section 15 meters from the left support. That is the question. So, okay, that is the question. See, you can easily find out, sir, what is the normal thrust and what is the radial shear. We can't discuss it. We discussed it, but we can do directly problem. No problem at all. So that's, you can easily understand what is the normal thrust and what is the radial shear. Okay, so very simple, no problem at all. So see, it is 30 kilonewton per meter is applied on a span of only up to AC, not a throughout span. So okay, so you can solve very problem. Okay, see, it has horizontal thrust, it has a horizontal thrust H. Both are equal because there is no another horizontal force is there. If you see, if something like force is there, some 20, if it is there, so it will come like H plus 20. Are understood? So both horizontal thrusts are different. But if there is no another horizontal loading on the throughout the span, both supports, both horizontal forces are equal because Fx equal 0 throughout the span. Are understood? So that's it. So there is no horizontal thrust, horizontal force in another place. So both here equal, H. So what is the H? So we will find later. First we want to divide what is L1 and what is L2. So what is L1, what is L2? So you can directly write it. So you can directly write is what is L1? L root H1 by root H1 plus H2. So what is L? 40. What is H1? H1 is root 5 plus root 3. That's it, na? Root 5 plus root 3. What is that value? It is a 22.54 meters. So what is L2? L root H2 H1 plus H2. See, 40 root 3. What is that value? That value is 17.46. No need to calculate L2. So total is 40 minus 22.54. You will get 17.46. No need to find out the L2. Understood? Once you find out, that's it. So what is that value? This value is 22.54. This L2 is 17.46. So once you got, so no problem, no big deal at all. Okay, so once you got it now, so now you can find out the vertical reactions. You can easily find out. This is V1, so VA, this is VB. So take a moment, okay, take a moment with respect to C from right side, because there is no loading at all, na? You can easily find out. So you can easily write one of the equation. So what is that equation? VB multiply with 17.46 is equal to the H multiply with height 3. That's it, na? That's it. You will get like h is equal to VB into 17.46 divided by 3. 17.46 divided by 3. So 5.82. That's it. Now one equation you will get it. So later now if you take moment at a equal 0 throughout span, you take as throughout span. See, it is moment at a equal to 0, not a moment, it's a bending moment. See, not a bending moment, it's a moment. Okay, so bending moment also 0, but we'll take a moment. Okay, moment is equal to 0. So that's it. See, VB multiply with what is the total distance? Is a 40. Understood? VB multiply with 40. VB multiply with 40. So okay. So next this H. So this H, see, this H has a vertical distance. What is the distance? It's a 2 meters. 2 meters now. In the previous, if you see in the previous, if you like this, so this H directly passed through the support of A. There is no perpendicular distance. So in the previous questions, in the previous model, there is no movement from the horizontal reaction of other support, because this H directly goes to the other supports. So no chance. But in this support, in this problem, the two supports are different levels. So compulsory the movement will exerted from the another horizontal reaction. See how much? It is a 2. I understood? So VB into 40, same direction, same direction. VB into also same direction. So H into 2. Okay. So next, this loading is exactly off. So what is that exactly? Half distance is half distance is 22.54 divided by 2. It's 11.27. So okay, what is that load? Load is, that is a negative direction. Load is what? 30 into, so 22.54, that is the load, and distance is 11.27. That is opposite direction of moment existed. So total will get 0, because A is a hinge support. Otherwise also, okay. So moment with respect to any point also 0, any point. Okay, that's a basic equation. No need at. So what is that exactly? You see, what is H? H you can write is a VB into 5.82. Are understood? VB 5.82 multiplied with 2. This is equal to this value. So what is that value? 5.82 multiplied with 2, 11.64. Answer plus 40. So 51. VB is equal to this value. So what is a VB? What is VB? VB, you will get 140, 147.58. Okay, 147.58. That's it now. That is a VB. So what is VA? So remaining value. So what is the total load? Total load is 30 into 20.54. That is the total load. So minus, subtracted. What is the VA? What is the VA? VA is 528.02. That's it. VA and VB. Okay. So that's it. VA and VB. Okay. Once you got now, VA is what? VA is 528.02. VB is 147.58. That's it. Very normal routine problem. So, okay. So now what he asking? He asking bending moment. At where? At a section of 15 meters. At a 15 meters now. So now that is the task. 15 meters. So see, it is 15 meters. This is a 24. Maybe this. I will call it as this. There is a 15 meters. 15 meters. What is that value of y? What is that value of y? 15 meters. You can easily find out. How can you find out? So y is equal to 4h by L square x into L minus x. From left support, na? Left support you are asking. So what is 4? What is x? What is h? H is what? H is of 5 meters, na? 5 meters. 5 meters. So what is L square? So we have to take is a 40, or they ask only for this support. Now see, they ask this, this value. This is a y. We have to take L as a this complete parabolic. Okay, so this is L1. See, this is L. This is L. This is total is 2L. Like this, if it is taken as a this L, this is also L. Then only you can get the formula of 4h by L square into x minus 4h. Okay. So now you don't need to take this 40 as a L. You have to take, this is a L. This is a 22.54. So this is again 22.54 to take it. Consider like this. Are understood? So otherwise I will write it. So this is 5 meters. You want just taken this height. This height, na? This height you will write like this. This is something he asked 15 meters, and this height length is 22 point 22 point where is it? 22.54. This is 22.54. So what is the distance of L? So L you have to consider this. You have to construct like full. Okay, construct full. So this is also taken 22.54. Then only the formula is applied. Otherwise this is taken L is 2 into 22.54. X is 15 meters. L is 2 into 22.54 minus 15. Okay, that's it. You have to take in this. What is you will get like 4.44 meters. So otherwise, sir, I don't want to take like this. So you can take like this. You can take like this. This is easy. So you will get this value. How can you get 5 x square by y, na? So x square, what is x square? 22.54. X square by y. X square by y is equal to constant at this location. What is this location? So this distance is what? 22.54 minus 15. That is the distance, na? That is distance whole square divided by that's much. You will get like this. You will get this value. So this is something like y dash. So that y dash you will get 5 minus y dash, you will get y. That's it. This is total is 5 height. So you will get like this. You will add to 4.4. So you can get the y value from anywhere. Okay, no problem at all. So but if you apply this formula, this L square is to construct a full parabolic of same heights. Then only that formula is working. Are understood? So you will get that y value from this also. No problem at all. So once you got that y value, so you can easily find out the bending moment. What is that bending moment? So VA multiply with distance of 15. Okay, I write it. See, first I will explain it. VA multiply with 15. Okay, H multiply with height. H minus height is 4.44. This is a 4.44. See exactly this location. What is the bending moment? He asking. Bending moment. Okay, VA multiply with 15. H multiply with 4.44, and also this load. This load is there, na? So that load. What is that load? 30 multiply with 15. Okay, up to this 15, na? So the load is 30 into 15. That is the load. So and also centroid list 15 by 2. That's it, na? That's it. So that's the question. So bending moment at the location of 15 meters from left VA VA. Okay, so I will write it, otherwise I will write like this. It is 15. So VA multiply with 15 minus h into height of 4.44. Okay, height of 44, and also minus this load is there now. Load is there. So what is that load? 30 into 15 up to 15 and 15 by 2. That's it now. That is the bending moment. So what is that value? What is the VA? VA already known. What is that value? So where is VA? VA is 528.02. That's it. H is what? We find out the H. No, we never. We find out the H. So H is what? No problem here. H is 5.82 into VB. H is 5.82 into VB. What is H? 5.82 into VB is 147.58. So 858. 858.91. That is the H value. H is same for both ends. H is same for the both ends. Okay, that's it. Apply the H, and what is the value? What is the value? Value of, it's a 740 kilonewton meter. That is the bending moment. That is the bending moment. Okay, that's the bending moment. So next what they ask? They ask normal thrust and radial shear developed at a section of 15 meters. That's the thing they asked it. So you have to learn what is exactly normal thrust and radial shear. Now I will explain. See, it is something. It's the section is there, so no need. I will cut this. Something. Okay, something thus. Something that section. Something this. So if you see, it has some reaction is there, some reaction is H there, some V is there. Okay, see, it has some loading is there, something up to that location. Some load is also there. Some load is there up to that location. Whatever you find out that location, this location is there. So just say it is. It has at that point. It has some shear. Na? It has shear. It has a shear. Sir, what is that shear? What is that shear means? That V minus of the load. Some load is there. Something. It is a something. It is a 20. It is a 10. So what is that shear? Shear is, say, not a 20. If it is a 50, it is a 20. What is shear? It will 30. That is a shear. You know. So this is. If it is there, it is 20. It is 20. Its the load is 10. Its load is also a 20. Exactly what is the shear force at this location? What is the shear force at this location? You can easily tell. It is a 10. It is a 20. It's a 10. That is a shear force, na? So same thing. This is a shear force. Shear force is there. But if you observe it, we just cut that location. We have H also there. H also there, na? It's a H also there. Then only it is a equilibrium. Same H. Then it is the equilibrium position. So this is a equilibrium, na? There is a equilibrium situation, because if you see, total vertical forces are in X direction is 0, total Y direction also 0. Then only we can get the shear force. So that's it. But if you observe it, we distribute the loads into this direction. So inside, not inside, in the direction of the arch. That is a normal. Normal reaction. No. So normal thrust, we can call it as a normal thrust. You can divide, na? You can divide this V. So I will write. you can divide that V and H into n direction. You can easily divide. You can easily divide. You can easily divide. Okay, I understood. You can easily divide. And also same and V in the direction of, so normal. Normal means normal to the surface of the arch. Normal to the surface of arch. That is the Q. Can you tell it? So if you see, arch has some different direction. So this normal reaction is there, that horizontal reaction is there, but those two reactions we divide into the in the direction of the arch and perpendicular to the arch. Are understood? Sir, why it is? So why it is means no. But if you observe it, clearly observe it, the force, the moment is transferred from one location, one position to the other position. Towards span, it has moment is distributed. Na? Moment is distributed not only with direction of the moments. You see, like, you observe it. Some force is there. Okay, it's a 20, it's a 10, and it's 10, it's 2, it's 2. Moment is distributed by forces, only by shear forces. Moment is distributed from this total location. You see, this location is distributed from 10 into 2, na? 10 into 1, 10 into 2 by only shear forces. But if you observe in the arches, the moment is distributed, the moment is transferred, not distributed, transferred from one location to other location, not only by the vertical reaction, but the moment is distributed through this normal thrust. Sir, how can the moment is distributed from this also same for vertical reaction only, na? So vertical reaction only, but the vertical reaction we can distribute that vertical reaction. So if you just taken that vertical reaction, horizontal reaction, the inside of meaning is what? What are the elements are taking? The elements are taking by the normal thrust and horizontal reaction. But if you see in the normal reaction, in the normal situations, just a span is there, vertical reaction is there. The vertical surface only taken. The surface only taken. Surface only normal reaction is there. Not just vertical reaction is there. There is no normal thrust. But inside of the arch, we can easily divide the vertical reaction, the horizontal reaction into the, we can divide into the normal thrust and this radial thrust. Radial thrust means exactly the perpendicular to the normal. Exactly the plane is perpendicular to the surface of the arch. Okay. So these two, this and these two. So you can get one extra point is the moment is distributed, not distributed. The moment is transferred from one location to other location, not only from the vertical reactions, but it has through the normal thrust. But if you observe, what is this normal thrust, sir? What is this normal thrust, sir? That normal thrust is axial force. I understood. If you have something, this is some force is acting like this. What is that meaning? Exactly to the normal to the surface. What do you call it is? What do you call it is? That is the axial force. So if you observe it, in the arches, every location experiences axial force. But in a linear section, if you take in a linear span or straight spans, there is no axial forces. If you apply just vertical loads, you will experience only vertical shear, not in any axial force. But in the arches, it has a curved surface. If you apply the vertical forces, the forces distribution is changed like this. The every section or most of the sections experience the axial force. This N, this normal thrust is also called axial force. This normal thrust is also called axial force. Axial force. That's why, if you understand it, that is the why the moment is distributed, not a moments. The loads are distributed throughout the span by a moments and also by axial force also. That's why another one of the scientists say that the loads are distributed throughout the span not only by moments but some axial force. That's why the moments are considerably reduced compared with the linear span. In a linear span, the loads are distributed through moments only. That's why some of the sections has some moments is there, but the same loads are applied in the arches. The loads are distributed through moments and also some axial force. So some part goes to inside in the meaning of axial force, then the moments are considerably reduced. Some feeling, it's just a feeling, not an exact, it's just a feeling. Just observe it. The loads are distributed throughout the span. The loads are taking. The loads distribution is happening at some particular location. You applied a 20, but throughout the span experiences some forces. The forces is in terms of shear force, movement, something like this. So that is the distribution of the loads. Understood? Distribution of the effect. The load effect is distributed throughout the span. In the linear spans, the load effect distributed throughout the span by moments and shear forces. But in the arches, the load experience or the force experiences is distributed throughout the span not only by moments, by some axial force. That's why some part is taken as axial force and some force is taken as a axial force and some force taken as a moment. So total effect, some feeling, it is taken as a feeling. So moments are considerably reducing. Sometimes some scientists explain like this. Okay, that is the meaning of normal thrust and axial force. Okay, so now we have to find out the normal thrust and horizontal. So this radial shear. This is the normal thrust. This is radial shear. If you see, if you take in this is the theta. That is the theta. If you see, V is there and H is there. You have to find out N and Q. Okay, so see it is. So what is a H and what is a H? Sorry, what is a V and see what is N and what is Q? Okay, see it is. So you can easily observe it. So what is N? So take in H by rule. So what is N is equal to H cos theta. Understood? This H distribution in terms of H in the direction of the N value. So we will divide that VH in direction of N and Q. Understood? So V and H are in perpendicular direction. No problem. N and Q also perpendicular direction. But we will divide that VH in the direction of N and Q. So if you take as N, so see it is H cos theta. H cos theta goes to in the direction of H. And also if you see N, so that's V cos theta. No? V sin theta. That's it. V sin theta. So in the direction of N, what will go? H cos theta and V sin theta. So same thing Q. What is the Q? So Q, you will get it. See, H, this theta is 90 minus, na? 90 minus. Same, in the direction of Q, how much force is distributed? How much H is going to be in the Q direction? Same, see it is, this is a H. This is a H. Okay? So like this is a N, this is a Q, this is H. So H is how much distributed through N direction, how much goes to Q direction. H is distributed N and Q, and also V is distributed in the direction of N and Q. We just divide it. So what is it? So negative direction, H is goes to this. So Q is downward direction. H is sin theta, and V in the same direction. V cos theta. That's it. That's it. So V and H, we divide those two quantities in the direction of N and Q. That's it. That's the simple. So like this you can easily find out the normal thrust and radial shear. Those V and H, we divide those two in the direction of N and Q. That's the thing. So what is the problem? The problem arises here is find out the Q. See what is the theta? What is the theta? That is the only problem here. Okay, only problem here. Okay, so now we will take in this problem. Now we will take this problem. So what is he asking? He asking find the bending moment, normal thrust and radial shear force and develop at a section of 15 meters. So that is the 15 meters, na? So that is the 15 meters. So we will write it again. We will write it same problem. That's why I given that is the example. Now we will take it. Okay, that is the direction. Okay, like this. This is good, I think. See it is. See it is. So from left support now. So what is the reaction here? VA is what? We will see it is HA. We know it. So exactly it is a 15 meters. He asking. So up to 15 meters, it has some load na? It has some load. It has some load up to 15 meters. 15 meters. So you can easily find. You can easily say that. You can easily say that. What is the reaction? What is the shear reaction? Shear force. Shear force at that location. What is the shear like? What is the shear? You can easily say it there because what is VA? What is VA? What is VA here? What is VA? VA is 528.02. So this is 528.02. So this is 15, 30 na? So uniform distributed load is 30. 30 into 15. 30 into 15, what is that? 450. This is total load is, what is that load? 50 into 30 into 50, this is a 450. So this is 450, this is 528. So what is V? Remaining is the shear force, na? So at that location, what is the shear force? So 450 answer minus 528.02. So 78.02. So that is 78.02. And also at this location, we will get H. H is same thing. This HA. So what is HA? What is HA? H is 858.91. Okay. 858.91. So now it is exactly equilibrium condition. So if you see it is Fx equal to 0, Fy equal to 0. That is the equilibrium equation. That is exactly the static equilibrium condition. Exactly 15 meters. We will cut it the section. We will cut the section. Okay. Now if you see it, so in the direction of the arch, that is a normal thrust. That is normal thrust. So exactly perpendicular to the direction, this is the radial thrust. We have to find out n and theta. First you have to find out that is the theta. What is the theta? So what is the theta? If you know the theta, you can write it. Sir, what is theta? So theta is, if you already know, what is, y is equal to 4h by L square x into L minus x. You know it, na? So you know it. Know it? Know it. So this is y, this is x. So okay, if you differentiate it, what is it? If you differentiate dy by dx, what will get? So y and x na, see it is. This is y, this is x, this is x. So what is the differentiation? Differentiation will give what will give? Differentiation will give slope. I understood. Differentiation will give what will give? Differentiation will give slope. What is this? This is the theta, na? This is theta for this location. This is theta. Thus theta is at that location. So what is the theta? Every location theta is changing. It is not a constant. Every location is not a constant. So we have to take at that location. At that location, what is the theta? So it is 15 meters. At 15 meters, what the theta? Theta is changing. If you taken this is a straight line. This is a 5. This is 2. What is theta? 5 by 2 is the theta. Y by x is we get theta. It is a straight line, but it's not a straight line. So it is a parabolic. So every location theta is changing. Every location theta is changing, like this location theta is there. Every location theta is changing. Every location theta is changing. So we have to take in that what is the theta or change in slope at that location. What is that? So we know the equation. We will differentiate at that location. We will differentiate at that location. Okay, at that location. So what is that value? If we differentiate it, what will get? 4h by L square is constant. So with respect to x. So if it is Lx minus x square, na, that is, so differentiation will get L, but x 2x. X square will give 2x. Understood? This is the theta. This theta is this theta. Okay. 4h is, this is a 5 meters, na? For this span. For this span, what is that span? So this span is 5 meters. You know it. So 5 meters. L, what will take? L is not taken 40. So L you have to take. L you have to take for this. This is 5 meters. So this is 22 point something. What is that? That is a 22.54. So you have to take an L is like this 22.54. Okay. So 22.54 into 2. That is L. Total L. L square. What is L? 2 into 22.44 minus 2 into x. X is at what location we have to find? 15 meters. So slope is changing every section. We have to find out the theta at that location. So x is 15 meters. So that is the theta. Okay. So what is theta? Theta you will get 8.44 degrees. 8 degrees 44 seconds. Maybe you will get from this equation, you will get into radians. You will get into radians. You have to change that radians into degrees. Okay. You have to change that radians into degrees. You have an idea how to change the radians into the degrees. Okay. That is theta. So once you got theta value, now it's a problem. It's over. Once you got theta, you can easily find out. So what is N, normal thrust? What is N? C it is. What is normal N? C. You can easily observe it. H into, what is N? H into cos theta. You can observe it now. H into cos theta. H cos theta. V into sin theta. So V and H are distributed. V and D are, we are the proportion, the quantity, or not a fabrication, the effect of H in the direction of N, the effect of V in the direction of N. We have taken that, na? The effect of H in the direction of N. So we distributed that force. H force is distributed in N and Q direction. See, if you just observe it, this is H, this is N, this is Q. So we will distribute that H force into the N direction and Q direction. Same V force also we distributed in the direction of N and in the direction of Q. Okay, just see it, H cos theta and V sin theta, and Q is see minus H cos theta minus H sin theta V cos theta. We observe side directions also. Radial direction means inside. So normal means normal direction. Okay. So taken, write it, find out the values, find out the value. Find out the value. So normal thrust is 825 kilonewtons. So radial thrust is minus 48.34 kilonewtons. Minus means the radial thrust is going to be negative direction, opposite direction. We taken this direction, but it goes to upward direction. That's the problem. That's it. Those are the things: radial thrust, and normal thrust. Okay, that's the problem. That's the problem. We solve it. Okay, so you can solve any loading. We'll take some simply supported load. You can solve any type of loading, and you can find out normal thrust and radial shear. Okay? Radial direction. Radial shear means radial direction. Radial direction means what? Radial direction means what? If you take in circle, what is radial? Radial direction means, so if you see taken, this is a normal, this is a radial. Radial means what? Inside of the radius. inside of the core, that is the radial direction. Okay? So you already know accelerations, normal acceleration, radial acceleration, fluid mechanics. Okay, normal acceleration, if something one rotation is there in a fluids, so viscous flow, non-viscous flow, inside of the radius, what is the acceleration? The radius, no? Radial direction, you already know what is the radial direction. In a fluid mechanics, so many problems are there. Okay, so that's why I explained like this: what is the normal thrust and what is the radial shear. Why we divide that into the direction? We can easily say that what is the axial force at that location. The axial force is this. This normal thrust is called. You can also call it the axial force. Axial force, but you can't in a linear. If you take it in a linear, you can't find out the axial force, because at every section it is a shear. If you have normal only, it's, if something is a horizontal reaction is also there, horizontal reaction also there, you can take this axial force. Something, maybe some of the spans are there, if both the hinges are there, you can horizontal force also develop. That horizontal force is axial force. But you can't find out the radial direction. There is no radius, it's a straightener. Both sides you can fix it. Some of the axial forces are there. Most probably concrete materials are not designed for the axial forces. Not a concrete members. Beams are designed for taken only for movements, not an axial forces. Okay, only columns are designed for taken as axial forces. Later you will learn next year. Okay, so that's it. This is the axial force, this is the radial shear. You can find out the like this. Okay, so I think that I clearly drawn the picture. I feel very proud. It's very good picture. Okay, so this is also I draw very good, I think. So that's it. You can solve any problem and any loading. So you can solve any. If it is a problem like this, it is a very easy. There is no nothing. 4 equations, 4 unknowns. You can solve anything. But if you give like this, it has some problem. So it has some problem. You can find out just L1 and L2. That is the only problem. Once you find out, everything is easy. But extra topic we learn today is normal thrust and radial shear. Okay, that's the enough. If you have